I would like to welcome all of you in this webinar that I am co-hosting with my colleague Gijs de Zwart. And as we have a small group this afternoon, I would like to keep it informal. I would like to also have it interactive. Maybe it's good to introduce myself first, and then it's even better to show you the program first. Let's do that first. The schedule of this afternoon. Let me see. I share my screen. So this afternoon, it might take a little longer than 2 hours, but we also would like to keep more or less to the schedule. So we start with an introduction and then with a global overview about what is SubD, because it's a new technology in Rhino. The next chapter is how does it work? So Gijs will demonstrate the most significant features of subdivision modeling. We also will focus a little bit on the pros and cons of SubD modeling compared to Nurbs, because there are advantages and disadvantages. Another useful feature of Rhino 7 is the quad remesh command combined with subdivision modeling, and especially, for example, reverse engineering is interesting to do that. As I am having a background of naval architecture, I'm also interested to focus a little bit on the maritime industry with a vessel hull example. And the last bit of this webinar is also that you can play yourself a little bit with the scooter exercise. And yeah, Gijs will show some small exercises, and then you can play with it yourself. So you also have some hands-on experience with subdivision modeling. I assume that everyone has Rhino 7. So if you don't have Rhino 7, you can just take a look at this scooter exercise. But maybe you can write in the chat if you don't have Rhino 7, so we know if one or more people don't have Rhino 7. I have one thing that I would like to check the participants, if David is in the waiting room, but he's not here yet, so too bad for that. And we also have some Q&A. We can also do that during the session, and I will have to activate also the, let me see how I can do that. Oh yeah, over here, the chat box. Well, I will do it later. Maybe it's good that I give a little introduction about myself. I started using Rhino in 2001, and I like to do some innovative boat design with Rhino. And later I became a Rhino reseller and started the RhinoCentre.
Gerard?
Yeah.
Can you stop sharing your screen?
Yeah.
Thanks.
Because of. Okay. Yeah, David is not in the waiting room. So in Rhino, which is based on Nurbs mathematics for surface modeling, later in Rhino there came T-splines plugin for subdivision modeling, and both Gijs and I have used T-splines extensively. But as T-splines was purchased by Autodesk and the T-splines plugin was discontinued for Rhino 6, McNeil decided to develop subdivision modeling features for Rhino 7. So that is what happened, and it's some sort of a new approach to modeling, and it's very important to decide which type of objects are interesting for subdivision modeling and which types are maybe better to do with the good old Nurbs modeling. Yeah, so I have some experience with modeling ship hulls with subdivision modeling, and in the past also with the T-splines plugin, I did some projects. I think it's time for Gijs to yeah, talk a bit about yourself. And
thank you. Well, I'm Gijs de Zwart. I'm an industrial design engineer, and I've also been using Rhino for quite a long time. Actually, I now understand even longer than Gerard, since 1999. So that's more than 20 years of experience with Rhino. I've been also teaching Rhino quite a lot. First of all at Philips Design, later on also together with Gerard. And at the moment, I'm also a teacher at the Design Academy in Eindhoven, where I teach every year about 180 students in Rhino. And furthermore, I'm a freelance designer, so I use Rhino daily for product design, but also design visualization using V-Ray. So that's in short what I do with Rhino.
great. I'm curious, which one of you already has some experience with subdivision modeling, or with T-splines, or with other software for subdivision modeling? So people can speak out or write in the chat box.
I played around a little bit. So we investigated T-splines a couple of years ago, but we never really got deep into it, except then testing our way, and that's pretty much the same I did now with SubD when they came with Rhino. Myself, Gabriele, Burak, Dachin. I mean, we're quite a bunch from the same company working with hull design, and we see an interest in SubD for what we call twin skeg vessel, which you may know what I'm referring to, Gerard.
Yeah. Okay, that's interesting. I will show an example of subdivision modeling for twin skeg arrangement.
Yeah, that would be interesting. Yeah.
Yeah. Okay. Someone else, please. I'm curious. I read that Mitch uses ZBrush.
ZBrush.
Oh, ZBrush, yes, of course.
Yeah, I typed it wrong. So my interest is as a hobbyist. I have a relatively large 4x4 by 14-inch 4-axis CNC machine in my basement. Everybody needs a hobby. And I use ZBrush all the time to clean up photogrammetric models. And but for intricate sculpting, I'm losing patience. So I've been using Grasshopper a lot to generate parametric models. And we want to clean up the interface between Rhino and ZBrush and then the CAM program. So that's my interest. Gerhard, a long time ago, I think we met on the Rhino exchange, on the Rhino website. And you had a little thing that would allow me, a little plugin that allowed me to do some half-hole designs.
Okay.
So glad to be here.
Well, nice. Nice to hear about your experience. I read that Da King, a colleague of Nicholas, has no SubD experience. And I think that's also nice about this webinar that, yeah, in the end, we will play a little bit with the scooter. If I take a look at the schedule, I think it's time for Gijs to explain us a little bit about the difference between subdivision modeling and Nurbs.
Okay.
Is that all right?
That's fine. All right. I'll share my screen then. So, share desktop. Okay. So first, let's take a short look at what subdivisions actually are. And I will do that based on what we find on the internet. Subdivision surface, if you find that in Wikipedia, you can find that subdivision surfaces are actually some implementation of Catmull-Clark subdivision surfaces. And that is based on gradually refining a mesh and subdividing it until you have a smoother surface in the end. So every phase gets divided, subdivided, and then gradually gets smoother in subsequent steps. And the same will happen in Rhino. So if you compare the subdivision surfaces, you can learn that they look a lot like degree 3 objects. And I will show that based on a single subdivision surface. So if I draw a curve of degree 3, let's make it 20 by 20 by 20. So this is the shape. Let's put that aside for a moment. Now let's make a new face with subdivision surfaces. So like that. And finish it. And you will see that the shape of the subdivision surface I just created is exactly the same as my Nurbs curve. So the degree 3 curve. Now these Nurbs, these subdivision surfaces, I'll shade my view here, are now objects that can be modified based on control points, edges, and faces. When you have an object in subdivision surface, you can switch between the so-called smooth mode and box mode with the tab key. If I now Control Shift Select or Command Shift on the Mac, is that correct? My normally a Windows user, so I'll do it differently here. Let's move this away. So selecting edge mode. So I can now extract or extrude objects in this subdivision surface model. And then you see that a smooth model will appear while I do that. Okay, so that's one thing. The other thing is if you compare it to a Nurbs surface, so we create a simple Nurbs surface of degree 3. using a standard tools plane. So again, making a simple plane here. Switching back to full. And changing the degree to degree 3. So we have a 3 by 3 object here. And I'll move these points. And let's move these points also. And let's convert this to a subdivision surface, to SubD. As a copy, so I'm not deleting the input. And here we can see an important difference between subdivision surfaces and normal Nurb surfaces. If we look at the curvature of this one, then you will see that the curvature is quite smooth and it doesn't end in zero curvature, whereas subdivision surfaces at the edges will always be flat. At the moment, you cannot use curvature graph on these Nurb surfaces, on these subdivision surfaces. So what we'll do instead is duplicate the edges of that object and turn on curvature graph for those. And here you kind of see that they end in zero curvature at the edges. And also they're not as smooth as the single span surfaces. So that's something to keep in mind. Okay. Any questions so far regarding this? I don't hear anything.
Yes, the sorry, yeah, I was muted. The corners of your new surface, of course, are not sharp as on the Nurb.
Yeah, so this is something
No.
you mean for this object they're smooth now, and this is something you can change if you want. So turning on control points for this one. Right now these corners are smooth. You can turn them into sharp corners with the crease tool this way.
Okay.
We'll come back to creases in a little bit later. But that's the way to do it. Another very important difference with normal Nurb surfaces is that if I want to change the length of this, for example, I can of course do an extend surf that way, but it is rather limited. So at a certain point you get, I'm not sure how this works for longer extensions, but this seems to work quite well. It not always does that this smoothly. Let's see, so the structure stays the same. But in subdivision surfaces, however, you can add as much detail and remove as much detail as you'd like. And it doesn't need to be the same detail in both directions at the same time. So, for example, if I now move or extrude edges, for example, this edge, I can safely do so with a subdivision surface. I can also increase the density of a section by adding more control to the midpoint here and moving that edge to give an example. that. And you see, you don't need to end in
another
the same direction, or it doesn't need to be continuous in both directions. So this ends somewhere in the mid of this subdivision phase. And so at the moment I have a quad-sided surface here, and sorry, a five-sided surface here, and the other ones are four-sided surfaces. And you can clearly see this if you can convert this back to Nurbs with the to Nurbs command. Let's switch to normal mode. So to Nurbs. Okay, done. The result you get is still a lot of four-sided Nurbs patches. So if you explode this, then you'll see you have all those singular patches, and these are again just simple Nurbs objects, which are quite complex. And that's something to be aware of when converting back to Nurbs. To give you a bit better idea of what it can do, I would like to show you an example of what I've been using this technique for. So switch to this one here. I recently made a frame for a driver, and this is a frame for a driver of audio component. To give you an example of the final product, you see it in use. And this was actually milled from a solid block of aluminum based on a subdivision model. And actually, it's a combination of subdivision surfaces for the majority of the shape, and then combined with normal Nurb surfaces for the flat parts. So I'll have a look at that. And, so this is the complete model. We also have the, let's move this out of the way, the base subdivision surface. And that's this model. So again, this is the boxy mode, so to speak, and the smooth mode. And what I did in the end is mirror this one and then made a polar array of it to complete the complete shape. And for this, I used a little bit of Grasshopper. So let's take a look at that as well. So here are my, this is my base subdivision surface. This one I mirrored and made a polar array of it. So this is currently the way to apply both mirror symmetry as well as polar symmetry into a subdivision surface model. And this is then combined into eventually a Nurbs model, all within Grasshopper. At the moment, there is a limitation with this technique. And you see that at these points where you have more than four-sided faces, indeed, thanks. And that's because converting it from a subdivision surface to a joint subdivision surface in Grasshopper, we need to convert it to mesh join that and weld the vertices and then combine it back into a Nurbs model. So it's a little bit convoluted. This is mainly for doing a joint model during the development stage. And then at the end, what I would do is just simply close my Grasshopper and go to my base model and do the manual mirror and array. So I could do this and then make an array polar and join the model into one. Smooth, and that's it. And then you have your complete smooth model. Okay. Any questions for this one?
So why would you model this with SubD and not with normal Nurbs?
Yeah, that's a good question. In fact, this is just a complete free form shape, and my client really wanted this to be really organic. So every joint needed to be organic, and his vision was to make something that was not only visually smooth, but also in terms of airflow or acoustic airflow smooth. I'm not sure if that's really how this works. I'm not experienced with that, but that's the reason why we took this approach. And also a little bit of a experimental case, of course, because of the new technology.
Yeah.
And if you would want to do this with Nurbs, it's certainly not impossible, but it's really challenging, I think.
And can you show us the hotspots where it might be challenging? If you go to shaded view and then...
Yeah. So let's close this one here. Especially at these kind of transitions, and these, if you would do that in Nurbs, you would end up with a lot of blend surfaces to keep that smooth. Also, this transition here, it's kind of a flow from kind of sharp to smooth. It's like a soft crease, so to speak. And again, it's not impossible, but it's just a lot of work to do this smoothing in Nurbs modeling. That requires a lot of work and expertise.
Yeah.
Okay, so I do want to note some of the current limitations that's being worked on by McNeil, and that is regarding the continuity at those kind of star points in subdivision surfaces. So everywhere where you have a vertex that goes into more than 4 edges, or when you have a connection that has 3 connections, like here, you get more complex end results in Nurbs. So let's have a look at that Nurbs model again. I'll turn on the ISO curve for this one. So you see that here we have again 4-sided patches, and this is also divided in 4-sided patches again. And the continuity at those star points is a problem at the moment. I'll show you by extracting some of these faces and analyzing them. So isolate those, zoom on selection. And turn on also something new in Rhino 7, which is edge continuity. I'll just type it in, where you can analyze pairs of edges. And you can already see that at those star points, we have quite a bit of deviation here, up to 0.38 degrees of tangency deviation at the moment. So this is a large point of attention at the moment for the development of this tool. I'm not sure if that also really shows in the zebra stripes here. Let's have a look. And it's clearly visible.
Yeah.
Does that make it a naked edge?
It's not a naked edge, no. The continuity, the G0 continuity is always closed. That's not an issue.
Okay.
Because the amount of vertices always match in subdivision surfaces. So you have a guaranteed watertight subdivision surface. And watertight Nurbs.
Is there a workaround?
At the moment, what I would do, and that is only on Windows at the moment, because it's not a plugin available on Mac, but I would just delete these surfaces and use an Xnurbs patch for it.
Xnurbs is a plugin for Rhino, a third-party plugin.
And it can generate really nice surface for these difficult 5-sided patches. Much better than the normal patch in Rhino, which is kind of worthless.
And Gijs, do you have some contact with the Rhino developers, and is there an idea whether this will be improved in a Rhino 7 surface?
Yes, this will certainly be improved in Rhino 7. Just recently, a very important bug regarding subdivision surface was solved, and Dale Lear, who was the developer of this technology within McNeil, is very open about it and said they had to solve a really big memory leak issue first with subdivision surface, which they have now done. And now they can really focus on the more important stuff that is really important regarding this. And this is one of the points that is going to be addressed during the development of Rhino 7. If you still have T-splines, then I think it's possible to even bring your subdivisions back into T-splines and convert them there to Nurbs, because the T-splines conversion is better at this point. Yeah.
Is there anyone in this webinar who has experience with T-splines or even owns T-splines? If you can type it in the chat box, please. I'm curious because I don't know many people who have experience with T-splines, so I'm curious. But I would like to address if Gijs can show the whole object again, please. What Gijs mentioned is that this object can be modeled with Nurbs, but with a lot of blends and smooth transitions. So it is possible with Nurbs and challenging, but the most important aspect of subdivision modeling is if you want to edit the shape of it. So if you are in a design phase and you have this object and you show it to the client or to the manager, and then they say, well, make this a little larger and that a little smaller, then you have a big headache in the old Rhino Nurbs. I think Gijs will show some examples now, maybe.
I will show another thing I was working on, and that is this concept, and a good example of what you just mentioned. If you want to do some changes, for example, if this needs to be just a little bit longer, in Nurbs it's going to be difficult, and in Subdivision Surfaces it's a matter of turning on control points and starting to move those out or up or down. Let's see. Or maybe the client says, okay, this section needs to be moved a little bit more to the front. These kind of edits are really simple to do in Subdivision Surfaces. It would be tedious in Nurbs, and would completely increase the density of your surfaces as well. That would make the surfaces more complex and even more difficult to edit.
In many cases, you need to export, from Rhino to IGES or other 3D format, like for CFD or for customer. If we use SubD, how is that handled? Is it transformed in normal Nurbs or?
Yeah, so every subdivision surface can be turned into a Nurbs by the TwoNurbs command. And that's the kind of model that you could send to your client. So this is a normal Nurbs surface, just like any other Nurbs surface.
But is that done automatically when you export to IGES or something like that?
To be honest, I'm not sure, but we can test that. If I export this one to IGES. Okay. Let's just do the defaults.
Yeah. Yeah, I think it's the same as in T-splines, that if in T-splines you opened the T-splines model without having the plugin, then it was automatically converted to Rhino Nurbs. And
yep.
I think that Rhino also, if they find out that it's an SubD and you want an IGES, then it automatically converts first to Nurbs and then creates an IGES export.
No, you see it's automatically done.
Yeah.
Okay, thanks.
Does that mean that a SubD model done in Rhino 7 can be opened in Rhino 6 or 5 and be interpreted that it's read as a nub?
Yeah.
Okay, that's good.
Of course, you have to save it as a Rhino 6 or 5 model to be able to open it, but for the rest, yes. Another big advantage, I think, in subdivision working out a concept this way is the fact that you can work with symmetry. And this is done with the reflect command in Rhino. So it's not the command symmetry, but reflect. It's a little bit maybe counterintuitive. I'll give a simple example. So if I just draw a simple Nurbs object here, it's black. So normally if I make some edits here, it will be on one side, of course. And I can now turn this into a symmetrical object with the Reflect tool. Slide to there and choose an axis. Then I have to specify the side that I want to keep. So that's this side. Now you see a reflection plane appearing It's actually showing a red line there. And you have to be aware that you can only change now on one side of the model. So it appears as if you can do on both sides, but it is actually just fake. I hope they will fix that one, because I think it's quite annoying that you cannot make changes on both sides. But anyways, this is how it currently works. And you see there's also a slight display bug regarding symmetry at the moment. What's kind of funny with this technique is that you can also do this kind of reflect even if you're not at the middle of an object. So if I do a reflect again on this object and just choose a rather arbitrary line here, you see it also works. So you can do really weird stuff that way. Okay. So in this case, the whole model is symmetrical, and any edit that I make will appear on the other side as well. Okay.
It's nice to read in the chat box that Burak mentions that he has some T-splines experience long time ago, and Nicholas mentions that at SSPA there was a license but not used much due to lack of training, and that's what I also remember from my T-splines experiences, is that in the beginning, using subdivision modeling, it is a bit different than the sort of old school Nurbs surfacing. So it takes some time to get used to it, and yeah, it has some specific approach issues. So yeah, it takes some time to get used to subdivision modeling, but I'm quite satisfied with the way McNeil implemented subdivision modeling.
Also, I want to add that I found T-splines to be very buggy and lagging as well. So if you had a lot of faces, the model became slower and slower and almost impossible to handle. And I think currently even the subdivision surfaces are really smooth, and the implementation has been done really well. And so it's really the same experience as any other tool in Rhino. And it is very fast. So
yeah,
no delays at all.
There's going to be a fundamental difference between T-splines and SubD that makes SubD more efficient, because, as you mentioned, Autodesk bought the T-spline license 5 years ago, perhaps 4 years. But I see that they're implementing SubD in their tools. What is the difference between the two tools, really? Is it down to the mathematical representation that they are different that much?
There is a difference, and that is what the T-splines is named after. That's the T in the T-spline. So in T-splines you can have a T-joint, whereas in subdivision surfaces you cannot.
Maybe you can show an example later, Gijs, to explain it.
Yeah, it's a little bit difficult. I don't have T-splines on this.
Oh, okay.
Yeah. Maybe I can find something in the meantime while you're.
Well, what I remember from using T-splines is that it was very important to do some checks every now and then about whether the star points, the T points were not too close to star points, for example. And I really like the T-splines plugin, also the features, the commands. the radial symmetry, for example, was working fluently. But yeah, I'm surprised that McNeil was able to introduce subdivision at the level as they have it now. So yeah, it surprised me. Gijs, is it an idea that I show another comparison between Nurbs and subdivision modeling?
Yes, good.
Okay. Are there any questions so far? Because I still like to have it interactive.
Well, regarding the 5 corners, the start points. If you want to create a ship which should be smooth, are you going to show that?
Yeah.
How to solve that?
Yeah. I will show later some.
Okay.
Things.
Yeah.
So good question. Welcome, David. We are already a little bit in the introduction of the subdivision compared to Nurbs. I see that you are connecting your audio. I will show an example of a ship hull and share screen. And also I would like to. So in December, I offered the hull design and fairing training to 3 trainees from Taiwanese shipyard Lungte, and they manufacture a wide variety of ships and vessels. One of them is this type of catamaran, and then I have been playing a little bit with that modeling of that ship hull. So what we see over here is an example of individual surfaces. So I have several surfaces, and this is just Nurbs. And I think that, let me see over here, it is based on Loft curves and then surfaces, and then I trim them, and then you have this result. Another example, another way is to do it with subdivision modeling. So again, here we see one object, and this is a subdivision model, again with the reflect. So I only model port side, and everything is connected. So in subdivision modeling, you are able to create hard creases. So here we have a knuckle, or it's called a crease. And then it is possible to simply, for example, select this face, turn on my gimbal, and move this one out, and everything is connected to this face. And it's also with the reflect connected to the other side. So that way I am able to easily manipulate the shape of this object, and everything is attached to it. So in Rhino, with Nurbs, this would be one surface, and because we have a hard crease over here, this always has to be another individual surface. And then it is more work if you, for example, want to move this edge a little bit to this direction, because then you have to do it for both surfaces and maintain also the accuracy. So in theory, this looks all quite attractive because you have one object and you can simply play with it, and you can add details quite easily. And then I was also checking out some naval architecture fairing analysis. And then I found out that it's not so simple as it is. One very important aspect in the marine industry is that if you have a surface that you can analyze, as Gijs already displayed, the curvature graph. So for example, it's locked. Let me see. What? Where am I? I'm a bit confused. Let me see.
Is curvature graph working with SubD?
Misschien zit je in edge selection mode.
Oh yes, yeah, that's also funny.
It's really annoying, actually.
So this is the toolbar of Subdivision Modeling, and that's something that here you see some selection modes. So selection edges, faces, points, and also none. So Rhino assumes that I'm in SubD working mode, but this is ordinary Nurbs, so I have to turn off selection filter. And now I can show, for example, the curvature of this surface. And if I increase it, here we see the curvature of this surface. And this is very important in fairing ship hulls. In the U direction, it is 0 because it's a straight section. So the surface only has curvature in one direction, in the V direction. Another important analysis that we do in the marine industry is curvature analysis. And for example, the Gaussian analysis is an important for defining developability of ship hull strakes, and that's possible with add object. So here we see that apparently the Gaussian analysis shows maybe that it's not developable, but in the end I always do surface flattening, unroll developable surface, and this deviation is small enough, so over here this works nicely. However, if I now take a look at the subdivision model, which looks very nice, if I go to analyze curvature graph, it's not working. And that's really something important for marine industry. So the same counts for surface curvature analysis for the Gaussian, for example, or the minimum radius to detect planar areas. It doesn't work with subdivision surfaces yet. And that means that the only way to evaluate the quality of the surfaces is directly possible with, for example, glossy for fairing. So this is a visual approach, and now you can see, for example, over here that here it's not perfect in this area. I found out that this glossy for fairing is in many cases already very a good analysis tool, but in the end it's very important to prove the continuity with this curvature analysis. So that's a limitation of subdivision modeling right now, but especially in the design phase, when you are in conceptual design, it's extremely fast to build up a design with this subdivision modeling, because everything is connected and you can easily make it smaller, wider, more volume in the bow area, etc., etc.
Yeah, exactly. So for form finding, it's really ideal compared to Nurbs.
Yeah.
Is there any reason, by the way, why you have that crease on the top edge of the vessel?
Oh, here. If there is a reason for it.
Yeah, that crease, which is now at your mouse.
Yeah. You asked me the question why I have that crease.
Yeah, the crease that extends from where your mouse is now.
This one.
That one.
I don't remember. Maybe it's not necessary because it's an end of the surface. So I don't know. I don't remember.
No, I mean the vertical one.
Oh, this one.
Yeah.
Yeah, it's a good one. If I remove it, then you see another limitation of where we are. Let me see.
This was something that was also a problem in T-splines, because you could not always
remove crease. So here you see a limitation. If you have hard creases joining in one point and there is one soft crease, then you have this problem in the continuity.
Yeah.
So that's a good one that you mentioned this. And here we have, this is not a crease, this is a vertex, an edge. But this is another limitation of the current situation of subdivision modeling. So I decided to create a crease over here. Let me see. Okay.
How did you build up this model? Because the Nurbs surfaces were built up by Loft.
Yeah.
How did you build it up here?
Let me see. I did some testing I think I made a mesh and then I converted the mesh to subdivision. But it was not the most elegant conversion, as you can see. So it took me quite a while it's a very good question, Bas, but it took me a while.
So you didn't use Loft and then create a subdivision of that?
Yeah.
Oh, you did in the end?
First I modeled something from Nurbs surfaces.
Yeah, but it didn't work. Yeah.
A rough one, and then I converted. So you can convert a Nurbs surface to a mesh, and then you can convert the mesh to the Nurbs. But it's yeah, it took me a while, and I haven't focused that much on the most clever technique. That would be the next step in my sort of personal development in doing this specific job. So it's a good question. How do you do it? And this was quite challenging to have it in the subdivision. So it took me a while. And here, you know, what you can see here is the steps. So this is the Nurbs, and then you see the trimmed Nurbs, and subdivision, conversion, less points, I don't know where, match the reference, again less points, so I delete some of these ISO curves. Then I add a wave breaker. So step for step, and then here I do the reflect. So yeah, this is how I do these type of jobs. I always make a lot of right mouse click, duplicate layer and objects, and then I rename them in step 02 based on step 1 trimmed Nurbs, and then step by step I so here you see this was what I have been shown. showing. And then back to Nurbs, it shows like this. And now it's possible again to conduct some curvature analysis and do, for example, the Gaussian analysis.
Mhm.
And now you notice here that there are some problems in this area. But this is not a model that I have been focused on fine-fairing a lot. So this is not what I want. I don't want to convert my subdivision over and over again to Nurbs to be able to analyze the quality of it. So I'm eagerly waiting for these the continuity analysis tools.
Mm-hmm.
Can you show just an example very fast of if you have like 3-4 Nurb patches, how you would transform it in a SubD in a single one?
Yeah, I can maybe do that. Yeah.
Very simple Nurb, very simple, yeah.
Yeah.
Okay. Okay. Sure. Okay. So there are a couple of ways to generate those subdivisions, surfaces. The most easy to use is to start from so-called subdivision friendly curves. So if you draw a curve, it looks a little bit like a degree 2 curve actually. And this one I could extrude. And once I've extruded this one, then I already have a subdivision surface. Change my display settings, will quickly shade it.
Now the back face.
Yeah, the back face.
Yeah. That one.
Okay. So that's one way to do it. Another way to do it.
You use another type of curve.
Yeah, so it's called SubD friendly. You don't really need to do it this way, but if you turn on SubD friendly, then this is the exact shape of what the subdivision surface will be.
This is the curve command with the option SubD friendly.
Yeah. So if I do the same without this option, let's see if we can turn on the control points here. And snap to the control points. Here you see the difference. It has a kind of extra control points that you cannot edit. I just asked a question about it on the forum, and they said, okay, it's a fixed one and it needs to be there. So if we take the same curve from normal options with snapping to point here. So that's our normal curve.
And that's a 2 degree or a 3 degree curve.
This is degree 3 curve. Yeah. So now we have just a normal Nurbs surface, and we can also convert this to a SubD. And let's just delete it. And crease the corners. SubD tools. Not that one. So this was a Nurb surface converted to a SubD with a 2 SubD tool. And the other one was directly made from a SubD friendly curve. And what I personally often use is the Append face tool, and that's the first tool in the subdivision toolbar, where you just drag out a face. And I tend to do that using quads only. I prefer to work as much as possible in quads because of the eventual transition to Nurbs in the end. So that's the cleanest way to work. Okay, that gives me one face. From here, you can extrude curves in the edge mode and move them. And in T-Splice, you could actually use that icon to move and extrude at the same time. So in Rhino, you need to do it in 2 steps. So this could be another way to generate the same kind of surface. Another quick way here is if you want to add or append faces to an existing subdivision surface, is to use the Append tool from edges. And then you can just snap to an edge and generate a new one. Well, let's append to it, append to this one. And then from edge, again using quad type. So then you only have to make 2 extra control points. I find this to work easiest in box mode. So again, append to this one. And then from edge. Okay, so you can move really quickly between undo. And you can also merge these if you would need so. Stitch this one to that one, and then you can determine the location.
And I think that the question was, can you combine several surfaces into one subdivision? Is that correct?
Yeah.
Was that the question?
Yeah, yes.
So if you have existing surfaces to
If I have 3 Nurbs surface, can I merge them into one?
So if the surfaces are converted into Nurbs patch, then yes. So let's do that. Generate a simple Nurb surface here. And turn on control points. Same story here. Okay. Let's change our degrees. And let's move a couple of points and do a match surface. Curvature average. Now refine. Oh, well, let's make another one. And just match the last 2 points here. And not average this time. Okay, so we have 3 Nurbs patches here, and Let's convert them to SubD. And delete input this time. So we have 3 subdivision patches, and we can join them using smooth option. And now it's a single one.
Okay.
Nice. Yeah, thank you.
I read that Gustav mentions that yeah, in the marine industry, it is the symmetry is nice, that you can only you can model the whole hull, but only work on one side of the hull. That's very nice feature. And then the second question is, how is the reflect surface in subdivision behave once converted to Nurbs? Is it dead? Yes. Yeah. So when you convert symmetric subdivision objects to Nurbs, then it's sort of passive result. So yeah. Let me see. Yeah, sorry.
I have a question, Gerard. The way you showed with many layers, you had different steps to reach to the end.
Yeah.
I remember I used to do the same with T-splines, but perhaps it was a long time ago, but I was really not happy with all crashing all the time, and I was not saving as often as I should have, and then I was just angry, and sometimes hours of work was lost, and it was really not a good experience.
Yeah.
Is it because you also work like that? I mean, do we have similar issues with SubD? So you save very often, and you have different layers.
Yeah, maybe that's yeah, that's I think for anyone working with subdivision modeling, if I show, let me share my screen, because this is interesting for all of us working with subdivision modeling. When I was working at this model, my Rhino crashed also every now and then. So subdivision modeling is not perfect yet. So for me, it's very important. For example, if you take a look at this first conversion. Oh yeah. So what you see when I converted, I have many points over here. I can show it with the. So I have many control points over here and over here. And before I delete some of these edges, I make a copy of it and I rename it to less points. So if I am having regret of my results, then normally people can undo it. But if my computer crashes or I save my file and I open Rhino again, and tomorrow I discover that I deleted too much, then I have a problem. So for me, with T-splines, but also with a Rhino hull modeling, I always do many copies, and I always compare it with climbing a tree. If I climb a tree, I select, because one apple is hanging somewhere in that tree, I have to climb the tree and make a decision, go left, go right. And I always want to go back down the tree to move up in another direction again. And that's what I create over here in this layer management. So I have, before I make big changes, big edits, I always create a new copy. And I lost some work with making this example because yeah, sometimes I forget to save and Rhino crashes and the auto save was lost, and I was having the
that's
same.
A question from Gustav also. Can't you change the autosave settings to just save more frequently?
Yeah. So in the property menu, I open the properties. It takes a while. And here we are. And you go to files. And here you can save every, well, where you want to save and how frequent you want to save. So this is something you can consider.
But then you would actually, Gustav, you would have to do an auto incremental save. Otherwise, you don't have all these versions, because the autosave will just override every change you've been making.
Yeah, you can also do incremental save in Rhino here, but I like to keep it in my file. So I do manually every now and then, right mouse click, duplicate layer and objects, and I rename it, and then I continue working. So this way I can trace back my whole process. Okay.
Mm-hmm.
I think it's time maybe that Gijs already showed us some significant features of subdivision modeling. Are you willing to show us some more of the features of subdivision modeling, Gijs? With a little demonstration, not too long.
Let's see.
Just some of the nice commands. I stop sharing.
I'll do that. Okay. Yeah, so what's really handy about subdivision surfaces, I think, is that you can indefinitely refine and reduce the complexity of your design. And that's something which is much more difficult in Nurbs modeling.
So what you mean is that you can add local control, local details.
Exactly, you can add detail, but you can also quite easily remove detail, much more easily than in Nurbs, and you can also quite easily change the topology of your model. So for example, if I want to change the flow of these faces, which are now, I'll show, let's move this out of the way. So if I select one face here and select another one and double click here, then it selects a whole range of faces. So the same here. What now if I want the flow to be in this direction? I want this to be one kind of loop so that those are synchronized, so to speak. I could do that with merging a couple of edges. So I'll do that with the weld tool. So I'm stitching this one to that one. And now if I select the same ones, and now this has become my loop. And for example, extruding that one, now deleting these faces. And this one as well. Okay, so you see quite quickly you've changed the direction of flow this way. Another interesting tool is...
Can you repeat that extrude? Because I think that was a bit quick, and I think it's very an important... can you show us first the extrude command on one face?
Yeah, so if you extrude one face, it generates
can you show
four faces.
Yeah, can you also show us the icon where you find the extrude?
Yeah, I normally do that with the gumball itself, with this icon of the gumball. There is also I think it's this one.
Yeah, that's one. Yeah.
Extrude SubD. And then you can extrude it in any direction, free form. This is a little bit confusing at the moment, so now I'm drawing up. And then you get the same kind of extrusion.
And it's very
And
important.
if
Yeah. Sorry, Nicholas.
if I'm correct, you can extrude in different directions. There's an option on the gumball or somewhere where you can choose to extrude along the face normal also.
Yeah, so you can align your gumball to be auto-aligned with the object. Now it's aligned with that face. And I'm extruding in the direction of the face. Okay.
And I think that this example shows the power of subdivision modeling, because this is impossible to have these type of details in a single NURB surface.
Yeah, exactly.
Okay, so thank you.
This, by the way, is also a cool tool with Gumball, is that you can quite easily align a face with the world plane by simply scaling it to 0. You see that happening. And it works really well together with all the alignment tools as well. So set PT in the Z direction also works well. Let's see, point and vertex like that. And so now everything is leveled out at that plane. Okay, so another very interesting tool is to be able to bridge two objects together. Let's, for example, take a cylinder and keep it not solid like that. And let's make another one. Okay. And now I want to have that transition into this surface. So right now, if you see this one, this has 8 control points or 8 edges. And if we delete these faces here, then we also end up with 8 edges, and these we can bridge. That's the bridge tool. So selecting this loop, that's the first set, and then select the second set. And you see that Rhino makes a quite good guess of which edges to join. Now we have a fluent transition between the 2 points. Like I mentioned, removing detail is also really quick. So going to edge mode, double clicking on an edge and deleting it. Goes like that. Edge mode and delete.
Yeah.
Let's see if I,
maybe you can add a crease.
Okay, let's have a look if we crease this whole transition here. Personally, I'm not so fond of creases. Hardly use them because of you cannot really make a nice transition between soft and hard creases.
Yeah.
But let's see what happens here. So that it's the result of a crease.
Yeah. And
do the same here. Okay, crease.
And maybe it's good to mention that if you want a perfect round cylinder, for example, that you create a polygon.
Yeah, so that's actually the same as with a Nurbs curve. Then you can see, and then I can show the difference also. So if you want to move to a complete circle or make your subdivision surface fit to a circular object, then you need sufficient amount of control points based on your document tolerance. I often work with 1/1000th of a unit as tolerance. So if we rebuild this, you can actually preview what happens, because it's very similar to what you get in Subdivision. So if we rebuild the circle with 6 control points in degree 3, we get this deviation. With 8 control points, we reduce to 0.08, as you can see. And let's increase to 12. It's already better, but we need quite a bit of control points to get below that 0.01 tolerance.
For a perfect circle.
For a perfect circle, yeah. So it's always going to be an approximation.
Yeah. Okay.
Yeah, but this generally tends to match quite well with a circular object.
Okay. Due to the time restriction, I am thinking what is clever. Oh yeah, that's also Gustav mentioned. So the creases are not weighted. There is a significant difference, as you also mentioned. We define in Rhino and in subdivision modeling soft creases and hard creases. And as Gijs mentioned, he always tries to avoid hard creases. And a soft crease is something that you put more than 2 or 3 control points close to each other. So it looks as if it's a hard crease, but it is just a smooth transition then. If I can find an example later, I will show it. But I'm taking a look at the schedule. There was this point in our schedule about the pros and cons of subdivision modeling compared to Nurbs. And I think that Gijs addressed many of them already. And I did some compared to hull modeling and fairing. Gijs, what do you think? What can we add to that subject of the advantages and disadvantages of modeling with subdivision modeling? Or maybe there are some questions. People maybe question already some things regarding if I start modeling with subdivision modeling. So I'm curious. Gijs, can you add some?
I think that the main advantage is the freedom that you have, and the fact that you can really simply make smooth edits to surfaces and keep your surfaces continuous. So for 3D printing, for example, there's also a really big advantage, so that you always have a watertight model.
Yeah, the water tightness of organic models is an also important aspect. Yeah, for 3D.
By the way, one more important difference with T-splines I want to mention. If in T-splines you had, I'm not sure if I can really show this in an example, but let's just take a look at something simple. Okay. Even this one. If you would do this in T-splines, then you would get really bad results if you don't have a completely smooth transition. So in T-splines, you would have to extrude this edge in order to have a smooth transition at those points. And in Subdivision Surface, this is not the case. I'm not sure. Do you have Rhino 5 on and T-splines on that PC?
Yeah.
So if you generate this in T-splines, you will see that you get a really bad result at those corner points.
Yeah. Yeah.
That made it really difficult to work with open T-splines.
Yeah. Well, I think we have limited time, so I would like to focus on other aspects. But what I hear you mention, Gijs, is that continuity at star points is still an issue.
Yeah, at the moment that is really a weak spot of subdivision surfaces.
So if you want to create sort of end results with subdivision modeling, it is at the moment limited.
Yep.
Yeah. So subdivision modeling in Rhino 7 right now is more for conceptual design.
Yeah, I would say so. Although I see that many people already used it in production, but if you can reduce those start points to invisible areas of your model, then it's totally fine, of course. Yeah. Also, if you're modeling something that will be cut and hand polished, there's no problem.
Yeah.
So,
yeah. So what I found out as a current limitation of subdivision modeling is the lack of analysis tools for curvature analysis, surface continuity, etc. So that's for me a big issue, because from a fairing point of view of ship hulls, you want to examine the quality of your result.
Yeah.
And it's not, yeah, it's not sort of useful to convert over and over again to Nurbs and then analyze that Nurbs.
Not sure if this works, but extract random mesh.
I'd just like to add a point to what you said, Gerard. For naval architecture, we work a lot with analysis of the stations and water lines. But what I could see, I found somewhere on, must have been on RhinoCentre, a Grasshopper model that allows to do that automatically. Then you can get this analysis done, even with SubD models.
Yeah, you can, for example, make maybe a Grasshopper script and then analyze the lines plan in Grasshopper.
Yep.
Is that what you mean, Nicholas?
Yeah, that's exactly it is.
Yeah. So there are workarounds, but I think that what Gijs also mentions, the continuity at star points is extremely important if you do fine fairing of ship hulls. So that's a limitation. Then we get to the quad remesh. Gijs, have you
I'll give a quick demo of it. It's not really a full feature to reverse engineering example.
Yeah.
But I will just show the basics of that tool and what it enables you to.
Great. If Gijs likes to continue, then we take a look at quad remesh.
Okay, so I have three similar objects here. One is a mesh object, a Nurbs object, and a filleted Nurbs object. And quad remesh enables you to remesh with quad-sided surfaces or quad-sided meshes. Let's have a look at that. So quad remesh. And this, let's just fire it off and see what happens. Okay. So as you can see, this is the default result based on that object. So it follows the sharp edges, and also it follows kind of the flow of the surfaces. And this generates a mesh, but you can also generate directly a subdivision surface out of it. So again, quad remesh. convert to SubD, and let's now turn this off here. So I use this quite frequently to turn objects that are used for rendering into something with soft edges, because many objects often have, this is really unrealistic if you render it, but this looks a lot more realistic with these soft edges. So you can see it turns the model quite fluently into a mesh model or subdivision model. And the same happens here. So it can also handle meshes. That's almost the same. So let's take a look at this one here. It takes a little more time, and you can also see that here it generates some artifacts. Quarter remesh is certainly not a tool that makes no errors like these, and it seems to work best with these closed objects. Here you can define how many of the patches you want to generate. Let's start with a low version. Yeah, so you can also generate very approximated results this way. But it does detect that crease there. Let's do the same here. So 100 to start with. This is also a really handy feature that you can hide your input. But as you can see, it generates these oval shapes because of the limited amount of target quads. So this is something you need to play with a little bit in order to find the correct amount. And there's a lot of options in there as well. So you can also make symmetry in your model. Let's see what happens in Y here. Looks a bit weird, isn't it? And
so what I remember from a demonstration that was done by McNeil was that many people who are in reverse engineering, you probably create a point cloud with a laser scan. Then the point cloud is converted to a triangulated mesh. And
exactly.
then you can easily convert this triangulated mesh to a quad mesh and then create a subdivision model out of it. And then you have a starting point for example, make an edit to that reverse engineering. So yeah, from that perspective, I really like the combination of quad remesh and subdivision modeling, because it's in some situations a very effective sort of technique to get to nice and high quality reverse engineering solutions. So yeah, thank you for this demonstration. Are there questions about this quad remesh, or is it clear? You like to show us some more?
Yeah, well, I was looking at a way to show the fact that you can also use a guide curve for generating subdivisions. Let's see if we can show that here in a simple example. So quad remesh and select guide curve and preview. So you can use guide curve to influence the flow of the generation of those patches. Now maybe this is a little bit awkward example. Maybe this works better. Let's see. And do a flow remesh. Previous, select curves. See that better. Yeah.
Yeah.
So curves can be used to influence the flow.
Yeah. So yeah, thank you for this example. I would like to continue with show some hull models based on subdivision modeling. So if Gijs can, yeah, already finish sharing his screen, then I would like to show some examples of ship hull models. Let me share screen. Over here we see a ship hull that is containing an aft build. And I can again show some of the steps how to get here. And I start with a pram type hull, and this doesn't contain this detail in the aft ship. So I convert it to a subdivision model, which shows more or less the same. Then I add the reflect, and now I do some steps in this region. I subdivide because I need more detail in this region. I subdivide over here this, what's it called, the face. And then I extrude it a little bit. And I move some edges. And then I do another extrusion. So it looks a bit weird. And now I move the bulb to an assist poly. So I have over here a polygon. And then I add some edges to create this polygon match. And now I match the polygon and I add a crease. Then I align the keel points and I create some extra detail. So I don't know where over here I inserted some edges. Again, because of the conversion of the Nurbs to subdivision, a little bit of the accuracy is lost. So I have to align, for example, the points of the side and the bottom and the bilge. So I do that over here. So that has nothing to do with the subdivision shape, but with creating a clean, accurate hull. And then I create some extra edges over here for the main frame. So this is the way to create an aft bulb with subdivision modeling. Bas Gores, who is also attending this webinar, has developed this Nurbs surface example years ago. And this is not subdivision modeling, but this is ordinary Nurbs. But as this aft bulb is a detail, a local detail, it's extremely challenging to do it with Nurbs surface, but it is possible with some tricks. So here we have the loft curves of this surface. Then you can create a loft surface that is protruding the center line. And then there is this assist plane. And if you trim this protruding part, this is the end result. So this is one way to create aft bulbs and maintain a single surface for this loft, because that is always the challenge. These aft bulb examples, many people have tried in the past to create it from several surfaces, and I can show an example and how it results then. I will open quickly. Yes. So what you see in the marine industry is that these aft bulbs, when people don't have the sort of proper education, it is very tempting to solve this problem with patchwork of surfaces. And I am opening now a Rhino file, and here it comes. It takes one extra second. So here you see what I sometimes find is that people start sort of creating a patchwork of surfaces to create this aft bulb. And if you go to glossy for fairing, you see that it's extremely challenging to create something that is fair. So this results in a lot of headache, and that's why I really liked Bas's solution to create these type of aft bulbs. But especially in the case of reverse engineering, if the accuracy to the original hull is very important, then this might be too challenging, this solution. And then I really like this subdivision model. So it's also easily adaptable. So I can now quickly say, okay, I want, for example, this edge with the gumball, move this one a little bit to make more volume in my aft bulb or less volume. And due to the reflect, it works both sides at the same time. And I can easily move this point a little bit down or to this direction. And the continuity is always maintained. As we learned earlier this afternoon, these points are still problematic in subdivision modeling. The same is, this is the 3 vertex point. So these are still challenging for Rhino SubD modeling, but for conceptual design, it's really fast. And again, in conceptual design, it's also useful that you can quickly analyze the hydrostatics, center of buoyancy, etc. So that's why I like this subdivision modeling already for the marine industry, but it's far from perfect for final fairing. Then I understood that there was also this interest in twin stack arrangements. So I made this example earlier. This is a technique that I developed at RhinoCentre for reverse engineering. So what we see over here are so-called reference ribbons from, so if you, for example, think about reverse engineering of an existing ship hull and you want to create a subdivision model of it, then the original ship is based on these orange and green reference ribs. And now my new subdivision model has to be within the tolerance of these reference ribbons. So, and it's arbitrary because over here the reference frames are plus and minus 265 millimeters, which is rather a sort of rough accuracy, as you can see. But for an example, it shows the functionality. And these twin stack arrangements are extremely challenging if you want to model it with ordinary Nurbs surfaces. So what we see over here, it's doable with subdivision modeling. And now I can, for example, tune the shape of this subdivision by, for example, selecting this face, turn on my gumball and move it a little bit in this direction to match better my reference ribbons. So maybe are there some questions about what you see over here?
Can you share the model? It's useful for us to see the topology you use.
So can you?
If you can share this file with us, because it's nice to see how you organize the patches and everything.
Okay, so with the SSPA, you like to? Okay, yes, I can consider that.
Even if you deform the shape, but just to see the topology you used.
Mm-hmm. Yes. So I think my first answer is yes, and I will rethink it. And so I think that I will share this with you. So thank you for asking.
Thank you.
There's one other question from Dakin.
Mm-hmm.
Is if there's a rule of thumb for making loft surfaces, how many curves you need for that loft technique?
Oh, with that other example.
Yeah.
Yeah, that's a whole different discussion. Let me see. Is this visible? Yeah, I think I shared this whole screen and not only. So you see this. So here you see the loft curves, and the question is, how many loft curves do you need for a proper job? Is that correct?
Yes, that's a question.
Yeah.
And I also wondering, do you need to put some stem curve at the bow and the stern to make some boundary there?
Yes, here you see that
in the bow you have some stem curve.
Yeah.
But not in the stern.
Well,
that's why that your surface extended over the central plane.
Yeah.
Okay.
Yeah.
So you let it go intentionally.
Yeah.
At the stern part.
Yeah.
Okay. Thanks.
Yeah.
But are there any rule of thumb that how many, because the geometry changes very rapidly towards the stern, from the midship towards the stern. So do you have any experience how many of those loft curves are required? For example, that you create, you start from some offset curves. You use those existing offset curves and then try to create a surface, a Nurbs surface.
Yeah.
How many of those curves you needed for a loft surface?
Yeah, that really depends on the challenges of the ship type. So this is what we practice in the hull design and fairing training a lot. So it really depends on the amount of shape. So in this hull design and fairing training, we do also reverse engineering to have a result that is close to the original reference. And it's not a rule of thumb that I can give you. And there are also more things that are taken into account. But what I think is most important is to start with less loft curves and then see how close you can get. And if you need more, then you can easily, for example, and we don't have that much time, but there is this command Tween Curve. So what I can do is say in between this one and this one, I want one or more extra curves.
Okay.
So I can say, for example, 2 extra curves, and they have the same amount of control points now. So now I can easily do another loft and do a loose loft. So now I have 2 extra control loft curves over here. But yeah, this is not something that has to do with the subdivision modeling, and the clock is ticking. So if it's okay for you, we continue the
Sure.
webinar.
Go ahead, please.
Okay. Let me see on the schedule. Yes, I think that it's time to play with the scooter exercise. Gijs, are you willing to guide us a little bit with the scooter exercise so we can see you doing something? So we open the scooter exercise ourselves, and then we can follow a little bit what you do, and we play a little bit.
Yeah, let's do that. Okay, so let's put this aside a bit. You all have this model open? Yeah, okay. So this model was made by one of McNeil's employees, Carl Houtjes. And he has extensive experience with designing in T-splines as well. And I think it's a really nice model that he made. And he's also a great designer. He can make beautiful sketches. And based on those sketches, he made this particular model. And you can see it's quite a simple model in terms of amounts of control points. By the way, there's a complete video of this available also, how he makes this complete subdivision surface example. So you can always watch that back. What I would suggest to do right now is just to see if you can modify the shape a little bit by moving control points and see how the subdivision reacts to it. That would be a good start. And let's make this my side view. Okay. Turning on control points and just see what you can do by moving around some control points and see how that reacts on the total shape.
Okay.
All right.
So can you, for people in Windows computers, so we turn on the control points and not the vertices or the.
Yeah, that's up to personal preference. I think for now it's easier to work with control points.
Yeah, and I do it myself too often. So
yeah,
but I don't want to go too fast.
So indeed, you can also go into SubD tools and go into this mode. So if I escape out of all my control points and turn on this mode, and then I can select individual points or select groups of points. But I think it's just easier to do it this way. Just select the object, turn on control points.
Yeah.
And then start manipulating a couple of those and see.
Yeah. I see a question from Mitch. I want to interrupt you. Mitch asks, where is the model? And Nicholas already answered. It was sent by email before the meeting together with a link to Zoom. So I hope that Mitch now also has the file open. Okay, so Gijs, what you show us is that you open the model, you turn on the control points, and then it is very easy to select one or more control points and start manipulating the shape of it. Exactly. Yeah. So what might be a nice challenge here is to see if you can make an adjustment to this surface so that you create a hole where this steer goes into without having to convert it into a Nurbs model. For this, what you can use is the following tools. Let's isolate this one. So we want to create local detail there. I can also subdivide once, create a little bit more detail in the model, and then manipulate at this location. So I'm turning into box mode, and I'm using this tool here to increase detail there locally. Let's do a reflect here. And keep this side of the model. And then delete these two faces. And then we already have something that is going in the direction of a circular hole. Let's show selected this tube here. And then start manipulating so that it fits. This is another thing to see. Now I'm selecting all those control points that are not in my view, and you can use Col control polygon for this. Then it will hide all the control points that are not in a visible direction. So let's move this out a bit. Probably need to turn up my grid step here. I'm a bit surprised that it is not symmetrical in this. Not sure if Carl has paid attention to that one. So let's move this right to the center, to a vertex. Yeah, not near. Do I have any thing turned on? So, wait. Yeah, so the aligning is now a bit challenging. Oh, I see. I have. Well, this is on Snappy Dragon. I'm not sure why I'm not getting these snaps here. You have an explanation for that? Maybe you are, yeah, in that mode. You have to change it. Let's try this one then. Yeah. This works. Yeah. Okay, so now it's symmetrical again. Now I can start moving this control point a bit. Yeah. Of course, we only have 4 control points to work with, so we can never get to a full circular hole here. So that means we would need extra control here. We could do that by inserting another edge here from
Let's do that also in box mode from this vertex to the mid. Then turning back control points, turning on control points here and start manipulating again. Yeah, that's already in the right direction.
Yeah.
Let's see if you
Right.
can do something similar.
Is there something that people like to see if we are, if there's a question, a sort of
Yes, Gijs, why don't you use cutting a hole by the shaft?
to trim it?
Yes, why don't you trim?
When trimming, you will convert to Nurbs.
Okay, automatically.
So you cannot have trimmed holes in Nurbs, in subdivision surfaces. You really need to stay in quarter triangular patches as long as possible.
And can you maybe show us how to model a tail light?
Yeah. So let's make something that
Or what's it
round,
called?
and I'll make a quick sketch here in side view. So let's say we would like to make something that goes from here, bit like that. Something like that.
Mm-hmm.
Okay. All right. Let's insert some details. And extrude these faces. Scale them. Actually, scale them. This, by the way, also an annoying bug in Subdivision Surface. Once you undo, you lose your selection.
Yeah.
Okay, and then move that up to there. And rotate it. Let's see how it looks. And then delete these. And start manipulating those 2 points here. let's have a look at how to convert this into something more circular. So if I'm aligning a C-plane by 3 points to this end vertex, to that end vertex, okay, and then I'll make a polygon. We have 1, 2, 3, 4 times 2 is 8. Let's do that between and then to that vertex. And I'll turn on control points again. And I'll move those to those endpoints. And then you create something more circular.
Nice.
Can I ask you something on this point? Let's say I want to run CFD simulations on this. So I want to simulate airflow, and then my task is to decide what diameter that should be. Can I connect that parameter to, let's say, Grasshopper, and then have 50 variants of it? I mean, that's like we're not using a curve anymore. So how do we connect, or how do we parametric turn this into parametric model? Is it possible?
I don't have experience with that, turning this into parametric. Do you, Kiat?
No. Let me think. Now, what I remember is that no, I don't think that that's possible yet. And I really do understand why, and that's also the reason that we use this rapid hull modeling methodology with loft curves. So you can, for example, do a systematic variation on the shape of loft curves. But if you have a surface and make it, I don't know how to do that. It's a very good and valid question, but I have no idea right now. I don't think Bas has an answer.
Well, I'm thinking if you use loose loft and you make a basic hull, is it then possible in Grasshopper to connect in Grasshopper via SubD? So you transfer the loft surface into SubD in Grasshopper, and then create a shaft which connects to the aft ship via a certain routine. So then that if you change your loft surface, then the surface is also parametrically changed, but still has the same shaft. Would that be possible already? And it depends on how far Grasshopper is with SubD.
Yeah. I don't think that it's currently possible, but it would be nice if you can directly manipulate the shape of subdivision. So what you want in Grasshopper is that you are able to connect to one control point in a SubD and be able to manipulate it. So I think that's the big question. Are you able to locate one control point of a subdivision surface in Grasshopper, and if you locate that point,
Okay. I can probably answer that. The answer is no, because it's not that structured at the moment.
Yeah.
I've been playing with scripting in this particular subdivision surface models and trying to manipulate those control points, and it was really challenging, to say the least. I've made a script to make these things round automatically, and it kind of works, a script, but I cannot say, okay, take this vertex and then take all the connected vertices in that order. There is no such order.
no.
They have arbitrary numbers instead.
Yeah, yeah. But I think that this is a big wish from the community. So I think that it will be a matter of time that some sort of solution will be implemented.
Yeah, I hope you're right, and I hope they kind of anticipated these kind of requests. And I'm a bit afraid the answer is no, but
yeah.
I'm not sure. I will have to ask Dale for that, I think.
Yeah. Yeah. It's nearly 5:30 local time over here.
I have an interesting question.
Yeah.
You showed us the loft method, but then you're still using the normal surface method in Rhino. But there is also a loft SubD.
Yeah.
Did you try that already?
No, not yet. And because the big thing is that for me that loft is just a starting point before I add the details. So if I just convert a Nurbs surface to SubD and then add the local detail, for example, for the half bulb or the twin stack arrangement, for me, it's not so important how I get to that starting point, but from the starting point, how I do the details. That's the most important thing. So, and I do think that it's also a nice feature to be able to loft directly to SubD from curves, but I have not played with it. But yeah, maybe something for the future. So I think that it's sort of time to finish this webinar, but we have some time left for questions. Are there some questions? I'm curious.
Yeah, thank you for the presentation first. It was really nice to see all the possibilities. I'm wondering whether Cage Edit is compatible with SubD. Do you understand what I mean? I think it was called Cage Edit in Rhino.
Cage Edit, yeah.
Yeah. As a way to control a surface, I'm thinking about the question from my colleague Burak. Then you could have a surface or a curve that then controls the SubD in the background.
Mm-hmm. It's certainly possible. If you do any transform that is possible in Rhino is also possible on the subdivision surfaces, but it will manipulate, just like meshes, it will manipulate the control point structure of the underlying mesh.
Yes.
So it just manipulates the positions of control points, basically.
Okay. Any other questions? Are there people who see opportunities for subdivision modeling? I'm just curious. Are people now, maybe also due to this webinar now, in a idea, well, now I can start myself? Or is it just a no-go? I have no idea. I'm curious.
The example you showed on the twin scale was raised some interest from our side, I think, because it's, as you said, with Nurbs, it's a lot of work to achieve a watertight geometry. So that's something we want to start with. I want to start with as soon as possible, indeed.
Okay, that sounds good. Yeah. Well, I would like to finish it for this afternoon, and maybe Gijs, are you finished? Is there something you like to share?
No, I think we covered pretty much everything we wanted to share today, and it was a was a good afternoon, I think.
Yeah. Any feedback about how we presented it this afternoon? I'm curious to hear your feedback. Was it informative?
Yes, it was. Thank you.
Good to hear.
Very, thank you.
Okay, you're welcome. Oh yeah, here Elaine types, I'm pretty new in Rhino and see very much opportunities in SubD. Okay. Well, nice to hear, Elaine. Yeah. And yeah, Gustav is also happy. So, well, I hope to see you again in the future. And for now, I wish you a lot of fun with Rhino 7 SubD. And last thing to mention is there is already many resources on the internet about learning to model subdivision modeling. So there are many free resources available on YouTube and via rhino3d.com. So yep. I think
I highly recommend to watch the series presented by Kyle Houches. They are really good.
Yeah. Yeah, Kyle Houchens, he is part of the McNeil team, and he makes beautiful instructional movies. Okay.
Yeah, it's nice to follow him. That's really good.
Yeah.
Thanks for being there, everyone.
Yeah. And have a good weekend.
Have a good weekend.
Okay. So thank you and goodbye.
Thank you. Goodbye.
Thank you. Thank you. Bye bye.
Bye bye.